Okay, let's get started. Just going to quickly introduce what we're going to talk about this morning. So we're going to talk a bit about deploying OpenStack and the challenges you can face when you're doing large-scale deployments. And in particular, we're going to dive into a bit of detail around the TripleO deployment project and our move towards using more Ansible and containerizing the OpenStack services. So initially, just for those of you I haven't yet met, quick introduction as to who I am. So my name's Steve Hardy, and I'm a software engineer at Red Hat. And I've been working on OpenStack for quite a few years now, and it's been an interesting journey when you've seen, the project as a whole and the number of projects involved has really increased enormously, and specifically related to deploying those services. There's a real challenge in terms of the scale and the how quickly things are moving within the OpenStack community. And initially, I started off working on the heat orchestration project, and then over recent years, it's been much more of a focus on deployment tooling and TripleO in particular. So what are we going to talk about this morning? So I'm going to take this opportunity to give you an overview of TripleO and the architecture we use to deploy OpenStack with TripleO. And we're also going to talk more about deploying and managing those OpenStack services and the benefits of using containers and the progress we've made over the last couple of releases with respect to containerizing OpenStack deployments using TripleO and Ansible. So we're not going to talk about running workloads on OpenStack. That's kind of an interesting use case for containers and Ansible as well, and there's definitely some overlap in terms of the tool chain, but we're not going to get into those details today. Just we're going to focus on the deployment of the OpenStack platform and the public or private cloud, your OpenStack environment that you're actually going to deploy workloads on. So let's just introduce TripleO for those of you who aren't familiar with the project. So TripleO is really not just an installer for OpenStack, and this is a common misconception where you do have some tools which are mostly about just bootstrapping an environment for development. You really need something which is going to help you with day two operations, and particularly upgrades and minor updates have been a historical pain point for OpenStack operators for quite some time now. And TripleO has been making very good progress in that area. We're making more use of Ansible to orchestrate major upgrades and minor updates. And we allow you to do everything in the life cycle, from planning your initial deployment and dealing with your inventory of hardware and the service placement in terms of where you want to run specific services on different groups of nodes. And then we do the actual deployment, which is provisioning the bare metal services and configuring the services on those bare metal nodes. And then the day two operations, where you need integration with things like centralized log services, monitoring tools, and as I mentioned, the day two operations around minor updates and major version-to-version upgrades. And so the first part of this on day one, when you're looking to deploy your production OpenStack environment, is you really need to do a bit of planning in terms of the bare metal resources that you're going to use. And one of the challenges if you're doing a very large scale deployment is you may not have all of exactly the same hardware, and you may need to group them. Perhaps you've got several racks of nodes with more disk which you're going to use for your Ceph storage, and perhaps you've got some which have got a lot more memory for your compute nodes. And we provide quite a nice node discovery and introspection capability based on OpenStack Ironic. This is kind of the TripleO mantra has always been OpenStack on OpenStack. And so where possible, we're making use of OpenStack services themselves to help with the deployment of the OpenStack environment. And so Ironic is working pretty well for us there. Ironic Inspector provides the ability to do introspection. And then you can register those bare metal nodes and optionally do profile matching. And so this is basically a rules-based approach where you can look at the introspection data and you can match, say, the nodes with more disk, or even down to, say, the specific version of BIOS you're using if you're working around a bug with some vendor driver or something. There's also a more simple approach where you can just manually tag, these nodes are computes and these nodes are Ceph storage. So there's quite a bit of flexibility around planning is kind of the key thing to take away from this. So this is kind of like a bit of an overview of the service placement flexibility. And this is another aspect. Once you've planned your inventory and you know which nodes are going to be used for what purpose, you need to figure out the way to deploy the different OpenStack services. And so originally, in the early days of TripleO, we had more of a monolithic kind of opinionated approach to deployments. We expected to have 3 controllers configured in HA, managed by Pacemaker, and then several types of storage node and compute nodes. But we rapidly found out that operators needed more flexibility than that. Partly for scale reasons, or maybe for operational and compliance reasons. You might want to run Keystone in a completely separated environment with isolated networks, and you may want to scale the database and message bus services independently because you're running a very large environment. And so we provide that via a concept called composable roles. There's an unfortunate naming conflict here, which is the concept of roles within TripleO isn't actually the same as an Ansible role, so that's just something to be aware of. A TripleO role is a group of nodes, so it might be the controller role or a custom networker role, which runs Neutron services, for example. And basically, you've got, within very few constraints, full flexibility to plan your deployments in this regard, including the managed services via Pacemaker, so we can run Pacemaker remote on the custom role for those services that are active, passive, and managed via Pacemaker in high availability environments. So this is kind of the final part of planning, which is the flexibility around networking. And again, in any production environment, you really do need flexibility around networking, partly for isolating the network traffic for security reasons, and partly for the ability to scale. So you might have a very fast fabric for some networks that are going to have very high level of data on them. And TripleO can handle that. We use a tool called OS netconfig, which is a tool that translates a declarative YAML syntax into network configuration, and that includes OVS configuration and bonds, bridges, VLANs, all of those kinds of things which you would traditionally do, maybe via scripts or Ansible indeed. We have a tool as part of TripleO which we use to do that. And so this is kind of just a summary of the things we've talked about. The takeaway is that there's quite a great degree of flexibility here. You can just accept the defaults out of the box, which is to deploy to any of the nodes in the Ironic inventory. But if you've got a large-scale environment, you probably want to start looking at some of these things in terms of grouping nodes explicitly, placing services to enable scale beyond kind of proof of concept size deployments. And the other aspect which I didn't mention explicitly was the predictable placement. And this is something which a lot of environments will want to have the Dymo tape on the rack where you always get the same IP every time you do a deployment. And TripleO allows for that as well. You do have the ability to do tagging of the nodes in Ironic such that you can say this is going to be compute node 0, and it's completely repeatable. So that's a pretty nice degree of control that you can have. The other aspect is just the inputs to TripleO are all YAML templates. So we use Heat as the primary orchestrator, and you basically have a Heat environment file syntax that allows you to version every bit of your configuration can just be checked into Git, and you can manage your infrastructure as code. So this is just kind of an overview of a TripleO deployment. And so there's a couple of key bits of terminology to be aware of here. So you effectively deploy a single node bootstrapping node, which we call the undercloud, and this is running some OpenStack services, including Ironic, as I just mentioned, and a few more that I'll mention in a few minutes. And then we use that to bootstrap your OpenStack environment, which is your production OpenStack cloud. And as I mentioned, we use Ironic to do the provisioning and several other services we managed to reuse. So you've got a nice symmetry between the undercloud OpenStack and the overcloud, which is the term we use for the deployed OpenStack environment. So this is kind of a slightly more detailed view of what goes on under the hood. So I've already mentioned Ironic a number of times. There are a few services kind of stacked on top of Ironic before we get to doing the node provisioning. And one which we've been making quite a lot of use of recently is Mistral. This is a nice workflow tool, and it's an official OpenStack project, and it provides imperative modeling, imperative orchestration for OpenStack. And if you need to specify a series of steps, perhaps for a major upgrade, for example, Mistral provides quite a nice way to do that. It's a very pluggable tool as well. So we've managed to have a couple of TripleO specific plugins that we're running specific to the undercloud environment. As I mentioned before, we're using Heap, which is more of a declarative tool. This allows you to build out groups of identical nodes, which are the custom roles I mentioned a minute ago, so groups of compute nodes and groups of controller nodes, and perhaps you might have multiple types of compute nodes, so compute with DPDK enabled and various other configurations which might be specific to the hardware if you've got multiple types of hardware and different pools of computes. And then behind that, we're using Nova, and this basically provides the matching I mentioned. Once you've tagged the nodes in Ironic, we use Nova flavors in order to specify the capabilities you wish for a particular group of nodes. So there's kind of a series of layers here. But the nice thing about this setup is that, the tools which are used to do the deployment are, to a large degree, the same as the tools you'll be using in your production OpenStack environment. So you kind of have to learn those tools, but only that one set of tools once. And so, yeah, it's quite nice. The domain knowledge is transferable between the two. I haven't mentioned Neutron yet, but we do use Neutron on the undercloud primarily for IP address management. So in the case where you don't have predictable IP addresses, as in a hard-coded list of IP addresses in your environment files, we can pick them from a pool of subnets which you've defined, and Neutron does the IP address management for us in that case. I haven't mentioned Glance yet, so TripleO has always been an image-based tool. So unlike some other installers which might install on bare metal and then do like package installs, this uses effectively a golden image from Glance, and it's similar to the images, exactly the same as the images that you would use for provisioning Nova VMs in a production cloud, and it gives you very repeatable deployments. And at a certain point in time, you can have another image which has been pre-tested. You can upload it to Glance, and then from that point on, new nodes will use that image. We also make use of Swift under the hood, so the Swift object storage service. We're just using that in a single node environment, but the nice thing about that is it provides an HTTP API to the various pieces of data that we need to use during the deployment, and so we call that the deployment plan. And so that's kind of the assembly of different pieces that we use. This is a more detailed, even further detailed diagram. I won't go into this in great detail because I'm mindful of the time constraints, but you can see here that we're using Mistral actions and Mistral workflows, which are all pluggable and configurable. So if you're interested in very flexible workflow tooling, Mistral is a nice place to start, and we found that it's working quite well for us in TripleO. So you've done all of the planning and the node categorizations, and we talked about the deployment a little bit now, and how we're using Ironic and an image-based solution to deploy onto your bare metal nodes, and we've talked about the Mistral workflow API. Now we're going to talk a bit more about our use of Ansible under the hood. So actually, I need to talk about operations for a moment as well. So I did mention day 2 operations before. So we've got integration with monitoring clients, Sensu primarily, and we've also got support for centralized logging. For many releases now, we've had full support for rolling minor updates, which have minimal downtime, and full support for major version-to-version upgrades. The major upgrades get kind of interesting when you start talking about moving to containers, because we've actually, in the most recent release, got full support for moving from a bare metal environment to fully containerized environment. So there are a few kind of interesting challenges around that I'll dive into in a moment or two. We also have full ability to scale up and scale down your nodes once you've done the deployment. So now we're going to move on to the TripleO and Ansible integration. So this is kind of interesting, where historically TripleO has had quite a large investment in heat templates, and we've really tried to make use of OpenStack orchestration to deploy OpenStack services. But one thing we did discover is that operators sometimes are more familiar with Ansible and other traditional deployment tools. We have, for several releases, been using Puppet, and our use of Ansible is kind of a recognition that when you need to start customizing or debugging deployments, that Ansible is a tool that most operators are quite comfortable with, and provides quite a nice operator experience. So this is kind of an overview of the architecture that we previously had. So we had some heat templates, and there's a heat config hook which knows how to drive Puppet, and then we would basically use Puppet to configure the bare metal services on the nodes. So this has worked very well for us for kind of a number of releases on bare metal platforms using packaged OpenStack services. The other advantage was we were reusing the OpenStack Puppet modules, which are a very mature system for generating config files and the bootstrapping that is required. But as I mentioned, there was this pressure to provide kind of an operator and developer access point, which was independent of the heat templates. And so this is kind of the stepping stone towards that which we've done during the Pike release. We have some quite strong constraints around backwards compatibility because vendor integrations and a lot of operator integrations are based on the heat template model, which is where we have a layer of composition for the different services and plugins for different service templates. So we didn't want to break that. We really need to keep that around for some time, but we wanted to provide the operator flexibility that people have been asking for. So we've basically wired in under the hood now. We drive Ansible via heat by default, and Ansible then drives Puppet and configures the bare metal. This kind of seems like a layer of needless abstraction until you get onto the container part, and also consider we've got this new command which is OpenStack overcloud config download. And this basically, once you've done your deployment, you can download some Ansible playbooks, and then you can rerun all of the configuration steps directly via Ansible. So this is pretty nice. It's a time saver for a developer use case, and also for an operator environment where perhaps you are debugging a pre-production deployment. This is a nice time saver. It shortens the feedback loop. And so far, this is working quite well for us. This is just a visualization of the deployment sequence that we support. Sometimes TripleO has been accused of being complex, but when you boil it all down, effectively what we're doing is we're doing some preparation of the hosts, and then we're doing a series of steps. So quite often there are dependencies in a deployment. So let's say you need to deploy the database first and the message bus, and then you need to deploy Keystone and perhaps create some users, and then you need to deploy some other services that depend on those previous pieces. We handle that in quite a simple way. We just reapply Puppet in a series of steps. So currently it's 5 steps. Now when you're driving it via Ansible, that's done via an Ansible loop, and when you do it via Heat, we use Heat software deployment resources. So when you move on to looking at deployment in containers, firstly, it's probably worth just reflecting on why we're doing this. There's a lot of interest around containers, and it's just sometimes worth taking a step back and thinking why they're going to provide value in your particular environment. So the containers for apps use case is well understood, but the OpenStack environment is kind of, there's quite a lot of coupling between services, and there are common libraries such as Oslo, where when you try and do a package-based update, the chances are it's going to be very difficult to upgrade just one specific service if you perhaps want to run a newer version of Heat for a feature or a newer version of Nova, which in some cases can be a useful thing to do. The other aspect is rollbacks, where traditionally you would need storage level snapshots and things to successfully roll back from bare metal deployments which have gone wrong. Containers provide potentially an easier path there. And so there are quite a few compelling reasons for this work, and from the Pike release, basically, we support deploying, or actually, all of the services can be deployed in containers, but we're primarily focusing on all of the services other than Neutron and Cinder, where we have support for those, but I'm aware that there are some vendor integrations that are not yet fully containerized, so we're kind of catching up on a few things there. We've got full upgrade support, so this is kind of interesting from bare metal. You deploy a bare metal environment with TripleO, and one thing which we've always supported is upgrading to the next major release. And the way we do that is under the hood, we basically make use of Ansible. We shut down and disable all of the services on the control plane. So the tenant workloads are not impacted at all, but we shut down all of the OpenStack control plane services. And then we basically run through an ordinary deploy sequence, which brings up the containers step by step in a similar way to the Puppet sequence that I just described. Now, one of the things we had to do was, to make all of this happen in one release, we had to look at ways to reduce the amount of of work required and also reduce the risk of regressions. And so one of the things we did there was not to migrate any data. So in the case of like the database contents, we've left that on the bare metal host and bind mount it into the containers. And we've made use of the same composable services architecture as we had before. So all of the heat level flexibility still works exactly the same. It's just under the hood. We do the translation into Ansible. So we've provided backwards compatibility, basically. We also have full support for the HA pieces. So this is the active passive services, which have traditionally been managed by Pacemaker. Those containers are still managed via Pacemaker in the Pike release of TripleO. We're still using host networking. So again, one of the kind of tricky things when you start looking at container orchestration is what you do with multiple overlay networks. And again, in order to reduce the risk of this switch towards containers, we've kept the OS net config layer, which I mentioned earlier on, and the host networking still works exactly the same. And we just use net equals host for the Docker containers for this iteration, such that we can focus on proving the container images, and the orchestration around bringing up those containers is all fine. And the other thing which I haven't yet mentioned is we also provide backwards compatibility with our use of Puppet. And so again, this is the thing which a lot of the vendor integrations and customizations that are performed for TripleO have made use of higher data overrides. That's the key value pairs consumed via Puppet. And we didn't want to break all of that. Obviously, you really don't want to break things without any deprecation period. And we wanted to provide a chance for a migration from the old to the new architecture. So this is kind of an overview of how we made that possible. There are a few more pieces in the mix now, and you can see that we still have the support for Puppet configuring bare metal. That's primarily used to configure Pacemaker on the bare metal host, and also to configure the Docker daemon itself. And in the case where you decide to run Neutron or Cinder on the bare metal, then you can have a hybrid deployment, basically, where some services are left on the bare metal host if they're not yet ready to be run in containers. And then we've got this interesting translation tool called dockerpuppet.py. And what this basically does is it spins up a container, which I should mention that we're using collar containers. We do have some template overrides which introduce a couple of additional pieces we need for TripleO, but we've had a good collaboration with the collar community, and we're reusing collar images for TripleO container deployments. But we basically have the ability to have this transitional step where we spin up a container which contains the service binaries and also Puppet. We run Puppet inside the container and then write out the config files back onto the host. So this is kind of a stepping stone to allow us to still maintain all of the Puppet modules and the maturity that I mentioned earlier on of the config management provided via Puppet, and also some of the bootstrapping that Puppet provides. We're still using all of that in this release, such that we can make incremental changes without having to re-implement all of the configuration layer which we're currently using via Puppet. And then there's a tool which is called Paunch, and this is basically a tool that allows declarative definition of the containers you're going to launch. And this then brings up the containers, and we bind mount in the config data and potentially do some more bootstrapping operations as well. And so, yeah, that's been a pretty nice tool. It has some nice features around idempotency, which have made upgrades of containers much easier, such that we can provide a JSON definition to Paunch, and then it knows whether or not the container definition has changed, and it will just restart those containers where something in the definition is different. So this is helping us to minimize downtime when we're doing minor updates. And in fact, in this environment, we'll probably have less downtime than we did with the previous bare metal architecture. So this is just another kind of diagram of the workflow I've just described. You can see it's pretty much the same as the bare metal approach. We still do the host preparation, which is the bare metal configuration to get the host ready for deploying the OpenStack services. We still do the Puppet bare metal configuration step by step, 5 steps, exactly the same. But we've basically interleaved that with 3 more steps associated with configuring the containers. So this is effectively the config generation, and that uses the Docker Puppet tool that I mentioned a minute ago. Then there's the container deployment. This is what actually brings up the OpenStack services running in containers, and that is Ansible driving Paunch. And then we have some bootstrap tasks, which is, again, we basically reusing the Puppet bootstrapping that we had used on the bare metal. We use Docker Puppet in order to launch a temporary container that does those bootstrapping, which is things like creating Keystone users and those kinds of things, and Keystone endpoints, things which Puppet has done for us historically quite well. And so, yeah, this is just an overview of what we talked about, and I wanted to just give a view of how easy it is. You know, we're using this Paunch tool. It's a single command line, and it can bring up multiple containers in one hit. And we basically write a JSON file for each step of the deployment. So in step 1, we'll have the containers for the database and RabbitMQ and some other bits. And then step 2, we'll bring up Keystone. Step 3, we'll bring up, say, Nova API. And yeah, it works quite well, and conceptually, it's quite easy to understand because you're just doing the same thing in a number of steps. So we've talked a little bit about Paunch already, but yeah, effectively the thing to understand is it's a wrapper for launching Docker containers, and it provides a declarative input, and then it figures out the workflow to restart the containers when they're changed or do the initial deployment of containers. It also has some hooks for doing bootstrapping tasks as well, which is pretty nice. So it's quite a flexible tool. It's not specific to TripleO. It could be reused outside of TripleO potentially. So yeah, it's worth taking a look at if you're interested in those kinds of problems. And yeah, there's a link to the Paunch OpenStack Git repo where you can find out more information. One thing I didn't mention is Paunch can coexist with other config management tools. There's obviously a multitude of different ways to start Docker containers. Paunch is only one of them, but it basically uses tagging to figure out the containers which it is managing. And so it can safely coexist with other orchestration tools. And also the idempotency features are nice. As I mentioned, it is able to make a decision as to which containers are restarted under which circumstances, which helps us improve the experience for minor updates. So we've talked a bit about Collar. I mean, this has been a real nice collaboration where we've managed to make use of the Collar containers, and we've had a really good collaboration between the TripleO community and the Collar community. You know, we're using a different approach to orchestration, which is fine. And we're basically reusing the exact same container images. One of the nice things about Collar is it does have a couple of hooks for customization. They have Ginger 2 templated Docker files, and we do have a couple of additional bits that we need to make the TripleO container images work the way we need. But other than that, they're basically vanilla Collar images. So this is just a little bit of a look under the hood as to how we handle the container images. So when you're going to do a deployment, you potentially have a very large number of container images, which one for each service, and you can actually have a separate container image for the Docker Puppet part, which does the config generation, and another container image for the part which brings up the service. The reason there is you may not want to have Puppet or any of the other pieces that we need for the config generation in the immutable container that you use for the service deployment itself. So that is very flexible, but in an effort to make this a bit more easy to use, Steve, who sat over here, in fact, has written a container image prepare command. So a lot of the TripleO command line experience is based around OpenStack client plugins. And this is another OpenStack client plugin, and it basically allows you to look at the plan. So we've talked about planning the roles that you're going to deploy and the services that are going to be enabled on those roles. The container image prepare command can consume that environment and figure out which containers are going to be needed, and then output a manifest, which is basically a heat environment file that is consumed on deployment. So that's working pretty well. And you then upload those to a Docker registry. This could be a Docker registry that you already have in your environment, or we do have support for a Docker registry hosted on the undercloud. You know, if you've got a very large-scale environment, you probably don't want to have a default where every single node goes and downloads from Docker Hub or some other remote Docker registry. And so, yeah, we've made the assumption that there's likely to be a local Docker registry and provide the option of using one on the undercloud if you wish. In terms of the deployment experience, if you have used TripleO before, one thing to mention is effectively the experience is very much the same. You just include one additional environment file. So these heat environment files can be combined to give you different permutations of deployment configuration. And we have one which is called, unsurprisingly, environments docker.yaml. And once you enable that environment, we will then turn on all of the service templates that define Docker configuration instead of bare metal Puppet-based configuration. And the end result will be a containerized OpenStack environment. So yeah, despite the complexity that we've kind of gone through in some detail, the operator experience can potentially be extremely similar to previous releases. And all of the things we needed to do under the hood are pretty transparent from an operator point of view. So that's it. We've talked quite a bit about containers here. I know that there are some other talks this week which you may like to get along to. This afternoon, there is a TripleO project update where you'll be able to hear more about the roadmap for TripleO and also a bit more detail on some of the other things not related to Ansible and containers that we've been working on. There's also, if you're interested in getting involved with TripleO, we're very open to additional contributors, and it's very important to us to try and grow a healthy community. And there's an onboarding session later this afternoon, which you can get along to. You can meet, a lot of the TripleO developers are going to be there, and they'll be able to give you information about how to get started and perhaps where a good place would be to start if you want to get involved contributing to the project. And there's also a talk around the same time, actually, which is more specific to Kubernetes. And I haven't really talked about Kubernetes integration, but it's something that we have started looking at. And a logical next step, now that we've got a fully containerized environment, is giving the choice to potentially do the deployments managed via Kubernetes, should you so wish. And so Flavio has been heavily involved with the TripleO project, and he's going to be giving a talk around his experiences with deploying OpenStack services on Kubernetes later this afternoon. We've also got a talk tomorrow around NFV deployments, and this is going to give you a bit more of a real-world insight into how TripleO can be used for more complex deployment scenarios. And then myself and Yada Kolfal will be giving a lightning talk on Wednesday around OpenStack in containers, where we'll be talking about some of the pain points and some of the good and bad aspects of our experiences whilst doing the containerization of TripleO work over the last year or so. So that's about all I have now. Here are some links. If you do want to find out more, you can come and find us at the project onboarding, but you can also chat to us on Freenode. We use the Paunch TripleO channel, and we also use the OpenStack dev mailing list. So feel free to ping us on there should there be questions. I think we've got a couple of minutes now. If there are any questions, I can take them. Sure. So it's pretty much the same as the bare metal case. I mean, the main benefit of the current iteration of containerization is dependency isolation. So it gives us, the ability to do mixed version upgrades or doing service by service upgrades, and it also allows much easier rollback. And potentially it allows you to do the updates a bit more quickly. If you do have a controller go down, so we use Pacemaker to do the management of VIPs and just will fail over to one of the healthy controllers, that still works exactly the same. We still use Pacemaker in the HA implementation. Although we're now using Pacemaker to manage the active passage services, the HA experience is basically the same as it was before.
So why was there a need for Paunch as opposed to using something like Ansible to drive the containerized deployment of OpenStack? What does Paunch really give you?
So, well, basically, it's been a stepping stone because previously we used a Docker command hook, which was a heat config hook. And basically, it allowed us to provide an easier migration path from our previous implementation, which didn't use Ansible and Paunch. It used heat templates to drive Docker commands directly. But Steve, did you have anything else to add as to the reasons why we've used that?
Yeah, I mean, that's basically it. It uses a subset of the Docker composed V1 registration format. So it's very simple. And done any number of things, but that's you saw the Paunch was being invoked like as a command line utility from Ansible. A perfectly reasonable next step would be to write an Ansible task like that.
Any other questions? No? Okay, well, thanks for listening, and I hope you enjoy the rest of the summit.